This is for specialist methods, the 2017 SAC for Calculus Tech Allowed, question number 7, and I'll talk you through some of the questions that you had. So in question 7, we have the cup, and there's 200 grams of boiling water in the mug. To the 200 grams of boiling water, centimetres cubed of boiling water, she adds 10 grams of powdered coffee. So the concentration will be the amount of coffee divided by the volume, which gives you that per millilitres. Okay, the coffee is too strong, so she adds boiling water at a rate of 10, but she also, out of a crack at the bottom, loses 2. So the volume is increasing in the cup. There was 200 and another 8 mils per second. 10 goes in, but 2 comes out. Okay. So to the questions that you have, if I go down to 7E, show that the anti-differentiation, so that the solution to this is this. That's what this question's asking. So I'm using separation of variables. I'm moving the y down here to get dy on y, and I'm moving the dt up here to get the dt over here, and I'm integrating both sides with respect to each of its variables. So that gives me this expression, -1/4 times that, so there should be integrals on that. So log base e of the modulus of y equals -1/4 log base e of 25 minus, so the derivative of that's 1. So she put 10 grams initially, so that gives me this c value. And if I move if I make that to the power of 4 and balance it with the 1/4, I can then combine those two logarithms together, multiply these together, and gives me this value. So then I've got log base e of y equals this. I'm going to move the 4 over to here, and then the 4 up to there, which gives me y to the 4 equals this. Why did I do that? Because I'm always looking at what's happening here. I've got y equals something to the 1/4. The line before that is y to the 4 equals that something. So that determined for me to move the 4 over here and raise it to the power of 4, which gives you this, which is exactly what you're asked to find. Then in G, you're asked, when will the mug overflow? Well, we know from right up in 4B that the total volume is this. This is the amount, the 200 that she poured in, the extra 8 per second. Therefore, it's going to take 22.94 seconds to overflow. That is, you've got this mug, you pour water in, you pour water in. When it overflows, that is, it's full, that's what we mean by overflow. The concentration, now I do think that you picked up an error in my solutions, because I've got an expression for grams, and it's the expression that we had to show here. This is the number of grams based on time. And we've got a little graph of that. It's going to stop at 23 because that's when it's going to overflow. And at 10, sub in, I get 9.19 grams. But that's not the answer to the question, because the question actually asked its concentration. So at 10 seconds, the volume is going to be 280, because it's going to be 200 plus 10 lots of 8. So the concentration should be 9.19232 divided by 280, which is 0.0328 grams per milliliter. And I think that's all the questions you have.